بسم الله الرحمن الرحيم. Welcome to the second part of the topic, which is verification of the trigonometric identities. We define the identities as an equation which is true for any value for the given variable x or theta. In the last part, we discussed some examples, and in this part also we are going to give more examples how to verify the trigonometric identities. Start with this exercise given by number 8. We need to verify these identities. And as we mentioned before, for the identities, we have one of the sides will be more complex than the other one, and we need to simplify this to get the other one. So we can take the left-hand side to get the right-hand side, or take the right-hand side and try to show that's equal to the left-hand side. In the question number 8, we have 1 over sine x plus 3 over cosine x equal to cosine x plus 3 sine x divided by sine x multiplied by cosine x. If we take the left-hand side, which is 1 over sine x plus 3 over cosine x. By finding the common denominator for both of them, or doing just like cross multiplication, I will have cosine times 1 will give me cosine x plus 3 times sine x is 3 divided by sine x multiplied by cosine x, which is the right-hand side. So it is done. Just we need to find the common denominator by multiplying the two denominators together, and I will have cosine x plus 3 sine x over sine x times cosine x, which is the right-hand side. For number 9, I have the left-hand side, which is cosine x divided by 1 minus sine x. In general, if you have this form, fraction divided by 1 minus sine or 1 plus cosine or 1 minus sine over cosine or over sine, we multiply the conjugate. So if you multiply this by the conjugate of the denominator, which is 1 plus sine x, up and down, multiply by the conjugate, I will have for the numerator, it will be cosine x multiplied by 1 plus sine x divided by. For the denominator, I have 1 minus sine times 1 plus sine. So for this, I will use the identity A minus B multiplied by A plus B equal to A square minus B square. So 1 minus sine multiplied by 1 plus sine will give me 1 minus sine square x. So to be cosine x multiplied by 1 plus sine x divided by 1 minus sine square x. But we know that also 1 minus sine x square, this one, or 1 minus sine square x, this is equal to cosine square from the Pythagorean identities. So this is equal to cosine x multiplied by 1 plus sine x divided by cosine square x. Again, this is equal to cosine square. Now I can simplify. Take cosine with the square. Then I will have 1 plus sine x over cosine x. Now we can split the fraction as 1 over cosine x plus sine x over cosine x. And this is equal to 1 over cosine is secant of x plus sine over cosine is tangent. We go back to see the question. This secant x tan x, which is the right hand side. This is equal to right hand side. That's okay. Done. So we verified that the left hand side equal to the right hand side. One example. Let's verify this one. Sine over 1 minus cosine equal to cosecant x plus cotangent. This is similar to question number 9. Just multiply by the conjugate and we'll get the same idea. Just multiply by the conjugate. This is similar to question number 9. See question number 11. I have 1 minus tangent to power 4x divided by secant square equal to 1 minus tangent square x. So let's take the left-hand side. I have 1 minus over secant square. Now for this one, I'm going to use the two identities. If we have a square minus b square, this can be written as a minus b multiplied by a plus b. This is the first identity I need to solve. And also we have secant square x is equal to 1 plus tangent. So the fraction now can be written as the numerator can be written as product of two factors. The first one is 1 minus tangent square x, because 1 is can be written as 1 to the power 2. Tangent to the power 4 is tangent to the power 2 all to the power 2. And 1 plus tangent square x divided by secant square can be written as 1 plus tangent square. Now I have common factor, that is 1 plus tangent square and 1 plus tangent square. I will have 1 minus tangent square, which is equal to the right hand side. So it is verified. So 1 minus tangent to the power 4x divided by secant square equal to 1 minus tangent square x. Take more examples. Suppose that we have this for question number 14, cosine x tangent x minus sine x over cotangent x, and we need to verify this is equal to 0. So the left-hand side for question number 14. We have cosine x multiplied by tan. So I can write it as cosine multiplied by tangent is sine x over cosine x. Minus sine x all over cotangent. Now I can cancel cosine with cosine, so I'll have sine minus sine will give me 0. So this is can be written as sine minus sine x over cotangent, which is equal to 0 over cotangent of x, that will be equal to 0, and this is the right hand side. Question number 15. The left hand side is given by sine x minus 2 plus 1 over sine x divided by sine x minus 1 over sine. Because I have sine in the denominator of each of these part of the fraction function, this sine and this one, I want to remove it from this denominator. So I'm going to multiply the numerator by sine x and the denominator also by sine x. This is just to remove the sine x from each one of these denominators. So we multiply now sine with sine x. I will have sine times sine will give me sine square minus 2 multiplied by sine is 2 sine x, and sine multiplied by 1 over sine, this will cancel this one, I will have plus 1. Same thing for the denominator, I will have sine square minus 1. Now, to simplify this, I will use the two identities. I have a square minus 2 ab plus b square can be written as a minus b square by special factoring. And the denominator, I have a square minus b square, which is equal to a minus b multiplied by a plus b. So this will give me the numerator. This can be written as square because this is perfect square or complete square. It is sine x minus 1 all to the power 2 using the first identity. The denominator can be written as 2 factors, sine x minus 1 and sine x plus 1. Now we can see that sine x minus 1 is common factor, so I can cancel this one with the power. This will give me sine x minus 1 divided by sine x plus 1. And this is equal to the right hand side. So this identity is verified now. The left-hand side equal to the right-hand side, which is equal to sine x minus 1 divided by sine x plus 1.